Hello, welcome to the TypeScript course. In this video, I'm going to teach you all these things that you are seeing on the screen right now. And by the end of this video, you're going to have a very clear idea about what TypeScript is, and you'll be able to use TypeScript in any of the projects that you want to work in. In order to understand what problem does TypeScript solve, let's take a look at this piece of code. Now, if I ask you which one of these lines would throw an error, you probably know the answer to this question. This first one, right, where we're calling the message. Now this is wrong because message is a string and not a function, so we cannot call this. Now take a look at this piece of code. Can you tell me now which one of these statements would throw an error? You cannot tell in this case. And the reason for that is because what you can do with x here depends upon the type of value x holds. For example, if x is a function, you can call x. If x is a string, you can call two lowercase method on that string. Okay, but what if x is an entirely different thing and you see a code like this? Now here, you do not know a lot of things like is x an object? If x is an object, is some random method present inside of that object? If the method is present, can I call that method? If I can call that method, does it require any kind of input? And so on, right? Now with JavaScript, variable data types are often unknown because of the dynamic types present in the JavaScript. Dynamic types essentially mean that a variable can hold any type of value. Now this is problematic for two reasons basically. First of all, it increases the chance of bugs in your code if you're not being careful. And the second thing is, you will only know about these issues after executing your code. Now for simple scripts, this is fine probably, as you can simply execute and see what is wrong right there. But any production app will likely have hundreds and thousands of lines of code. And you cannot test every possible case every single time. So using TypeScript is going to make your code more robust, especially if you are a beginner or if you are creating a very complex application. Now TypeScript is not only going to help you avoid writing code with bugs, it is also going to alert you if your JavaScript is not up to the standard. Let me explain. When we write code in JavaScript, sometimes it can have mistakes or problems. Now some of these problems are obvious and cause the program to stop working. We call these errors as runtime errors. But there is also this possibility that you could write your code in such a way that may not cause problems immediately but could be problematic in the long run. We call these non-exception failures. So non-exception failures are all those mistakes in your code that do not cause an immediate error but can lead to problems in the long run. TypeScript can help you find these mistakes so you can fix them before running your code. For example, if I try to access a property that does not exist inside of an object, JavaScript is going to give me undefined. But if I try to do something like this in case of TypeScript, it is actually going to tell me that you are trying to access a property in the JavaScript object that does not exist. TypeScript can catch different types of mistakes like typos. For example, if you misspell a function name, TypeScript is going to warn you. If you have declared a function and you are not using it anywhere, TypeScript will let you know about that also. If your code has a mistake in its logic, like if it's checking the wrong condition, TypeScript can also catch that. So to fix the issues that could happen because of the dynamic type nature of JavaScript and other things, we use TypeScript. Now TypeScript is a superset of JavaScript that adds static typing to JavaScript. In very simple terms, with the help of static typing, you can explicitly declare what type of value a variable is going to hold. And not just variable, what type of value a function is going to take as the input, what type of value a function is going to return after its execution, what type of data I am gonna be getting from an API endpoint, and much more. TypeScript also enhances the developer workflow by providing automatic inference, auto-completion, and documentation via types. We will take a look at these features a little bit later in the video. It also allows you to use modern JavaScript features. So what really happens is you write TypeScript and then this TypeScript code gets converted to JavaScript code with the help of a TypeScript compiler. Now we need this compiler as browsers cannot execute TypeScript code directly. So what that means, your TypeScript code in the end is just JavaScript code. So if you really think about it, all TypeScript is really doing is, it is just adding static types to JavaScript, and it only works during the development. So once you create the production build of your application, all of the TypeScript code that you have written is going to be compiled to the JavaScript code, and then this JavaScript will be sent to the browsers if your application is running in the browser. At this point, we have this clear idea of why to use TypeScript. Let's get started learning TypeScript. To be able to convert our TypeScript code into JavaScript code, we need a TypeScript compiler. And I can install TypeScript compiler in my computer by executing this command pnpm add TypeScript. I'm also going to pass -g, which is going to install this package as a global dependency. If you're using npm, the command for you would be npm install TypeScript and -g. I have already installed this package, so you can see that it is saying done in 601 milliseconds. Now, in order to verify if this package has been installed, all you need to do is just execute tsc --version. When you do that, it is going to give you the version of the TypeScript compiler that you have in your system. Okay, let me quickly create a folder called TypeScript tutorial. Now let's cd into this TypeScript folder, and let's actually open this inside of a code editor. Okay, so we have opened this folder inside of the code editor. I'm using cursor, by the way. I'm going to click on this icon to create my first TypeScript file. I'm going to name this main, and then as an extension, I'm going to write ts. This is all you need to do whenever you want to create a TypeScript file. Now remember, few minutes ago I told you that all TypeScript code gets eventually converted to JavaScript code. That means I can write all the JavaScript that I'm used to in this file itself. For example, I can write this console.log statement hello world, then I can open my terminal, and then I can tell my TypeScript compiler to execute this main.ts file by doing something like this. Now as soon as I hit enter, you will notice that it is going to create another file called main.js. And if I click on this, you will see the exact code that we have added in the main.ts file. So what really happened is when we executed this command tsc main.ts, TypeScript compiler basically compiled this file to a JavaScript file. And anything that I add here in this main.ts file is going to be present inside of that main.js file. So if I create a variable called message, so this is going to be a string, this is a message, and let's log this one also. If I now go to main.js, you'll see that we are not seeing that code over here because we have changed this main.ts file. So we need to tell TypeScript compiler to recompile this file. So I'm going to execute that same thing again. Now this time, if I go to main.js, you will see that we have all the code present inside of this file that we have added to main.ts. Now if you notice carefully, in the main.ts file, we have created the message variable using the let keyword. But in the main.js, we are getting this var keyword. And the reason for that is because by default, TypeScript compiler is going to compile your JavaScript code in such a way such that it just works with all of the browsers out there. You can obviously change this behavior, and we are going to take a look at that a little bit later in the video. And also you may have noticed this other thing inside of this main.ts file. You'll see this red line below this message variable. So this is our first hint that we are getting from the TypeScript, which is telling us that you cannot redeclare block scoped variable message. And the reason why this is throwing this error is because in this current directory, we have two files with the same variable name. So there is a possibility that they could conflict with each other. Now at this point, we have two problems to fix. The first problem is every single time I add something to this main.ts file, I need to execute this command again. And the second thing is I want to tell TypeScript that this main.ts file is only for the development purposes, and only the main.js file is going to be included in the final build of the application. So in order to fix both of these, we need to actually initialize TypeScript within our project. And you do that by executing this command tsc --init. So when you do that, it is actually going to create a tsconfig.json file. And just by creating this configuration file, TypeScript compiler has now this correct information that this is a TypeScript project, and all of the TypeScript file present in this project is going to be converted to their JavaScript versions. Now, if you take a look at this tsconfig.json file, you'll see a lot of options here. Okay, let me make this a little bit easier for you to read. I'm going to zoom out a bit also, more like this. So you will notice a lot of options present in this file, and you will also find a description what each of the option mean basically. Now let me quickly remove all of these comments and these options, and then we can talk about some of the important options that you should understand. Now the first option you need to understand is this target option. Target basically specifies which ECMAScript version do you need to target. And ECMAScript, if you do not know, is a programming language standard for JavaScript. It basically defines what is the valid syntax for JavaScript and what are the features available in JavaScript. Let's say your application will be running in an environment where the modern features of JavaScript is not yet present. So in that case, you can target an older version of ECMAScript like ES5. But let's say you only care about the modern browsers. In that case, you can target more like a recent version of ECMAScript like ES 2023 or 2024 or something. Now, if you want to also use some of the experimental features that are not part of the official ECMAScript standard yet, you can use a version called ES Next. And based on this target value, the TypeScript compiler is going to compile your TypeScript code in a version that is going to be compatible with your target. Let me show you what I'm talking about. So let's say if I set this to ES5. Now when I open my terminal and I try to compile my file main.ts again, then I go to main.js, you'll see that we are using var keyword over here. Okay. Let's say I want to target the modern browser. So for that, I'm going to be using ES 2024 or something. I'm going to recompile my file again. Now, if we take a look at main.js, you'll see that we are using the let variable, right? So it's just going to be a different syntax. And depending upon the target, you're going to get a different version with different syntax that is going to work according to your target. All right. Okay. Now the next option you need to understand is this module option. Module option basically specifies which module system do you want to use. Now there are multiple possible values for this. For example, you can go with CommonJS module system, or you can go with ES module system. You also have this option of AMD and UMD. Now each of these module system has their own pros and cons. So for example, if I talk about ES module system, and this one you write syntax like import package from package name. Now one of the benefits ES modules provide is that it works really good with bundlers like Webpack and Vite. And the second reason why ES modules are good is that it provides you this ability that you can get rid of unused code from your application. Now if you think about it, this is really important when you are building a web application or something, because in web apps you need to make your JavaScript bundle as small as possible. So that is why it is very common to use ES module system when you are creating a web app or something, or using any bundler to bundle your files. Now based on the module system that you'll be using, TypeScript compiler is going to be including a different kind of syntax for importing and exporting different packages. Let me show you what I'm talking about. So let's say I create a file called test.ts at the root of the project. Okay. Now this file is just going to, let's say, export default a function. We call this function greet. This expect you to pass a name for now, and then we return a string from here called hello, and then the name of the person, like this. Okay. Now if I go back to the main.ts, in this file I can actually import that. So let me import greet from that test file, and then I'm simply going to console.log. I'm going to call this function greet, and then I'm going to pass the name like this. Okay. Now do not worry about this error for now. Let me quickly compile this code by executing tsc, and then we need to take a look at this main.js file. So if you take a look at this main.js file, you'll notice that we are using this import statement to import the greet module that we have created. But if I go to my ts configuration file and change this to, let's say, CommonJS, and I recompile my file, go to main.js again, you'll see that we are now using a different kind of syntax like a require. And by the way, this required thing, CommonJS module system, is the default module system for Node.js, and it loads your packages in a synchronous manner. Similarly, I can go to tsconfig.json, and then I can also apply UMD, which is a different kind of module system. So UMD is more like a universal module system. So this is supposed to work with all of the environment. Now, when I compile my code, it should have a different kind of syntax altogether. So this is a kind of syntax that should work with pretty much all of the environment out there. But if you're like me, you're most likely gonna be using ES Next. That means ES module system. Okay, now the next option you need to understand is this lib option. This lib option tells TypeScript which JavaScript and DOM APIs are available in your project. Now this is important to configure because if you do not do this, you won't be getting the accurate types and automatic intelligence for the features that you'll be using in your project. Now, let me show you what I'm talking about. Let me quickly set this to an empty array for now. Now, if I go to main.ts file, you'll see that I'm seeing all of these errors. Cannot find name console. Do you need to change your target library? Try changing the lib compiler option to include DOM. Now, this is telling you that you're using something like console, and console does not exist in your project. If you are really sure that console is available in your environment, you should add its type to the lib option. And since my application is going to be executing in the browser where console.log will be present, I can be very sure that I can go to tsconfig file and here I can specify DOM. Now as soon as I do that, if I come to main.ts again, you'll see that I'm not seeing any of those errors. And now I can use any kind of DOM methods and properties, and TypeScript is going to provide all of the intelligence to me automatically. Perfect. So for the lib, if you are working on a, let's say, web application, two libraries you are most likely going to be having is DOM and then ES, let's say next, which is going to basically add types for all of the JavaScript features. And then you can also have some of the other option. I do not remember all of those things at this point, and that is not important, to be honest, because most of this stuff is going to be configured for you automatically using a tooling system like Vite or Webpack. Or all you really need to understand at this point is that something like these exist, so you can configure them later if you want. Alright, now the next option you need to understand is this root directory option. So if you take a look at this, our files are just all over the place. We have created these two files, main.ts and then test.ts. Let me actually delete this test.js file and test.ts file for now. Then I'm gonna go to main.ts. I'm going to get rid of this import statement for now. And then inside of this tsconfig, with the root directory, I'm specifying that this is where you should look at to find out the structure of my project. Now this is not gonna make a lot of sense until I show you the example. So let's say that I'll be putting all of my files inside of the src directory. So I can create a folder called src. I can move this main.ts file inside of the src directory. I can delete this main.js for now, like this. Okay. So with this, I've just specified the base directory of my project. Now what would happen is if I execute my tsc command again to recompile my code, you'll see that main.js is present inside of this src folder only. Now one of the things which I was confused in the beginning is that I thought when I've specified that the root directory is src, all of the TypeScript files that I am including in this src directory will be automatically compiled. Well, that is true, but with this root directory we are not specifying what TypeScript files TypeScript compiler should compile. Let me show you what I'm talking about. So imagine at the root of the project I create another file called test.ts. Okay, and then I'm gonna just add a console log. This is a console log. I'm gonna save it. Now if I execute my tsc command again, you'll see that it compiled this test.ts file also, which is present outside of the src directory, and it is also throwing you this error that your root directory is expected to contain all source files, but you also have other TypeScript file that are outside of that directory. So in order to tell TypeScript which file it should compile, below this compiler option, we can add this include option. And in here, I can specify that it should only compile the files that is present inside of the src directory. So I can say, let's only compile all the files that are present inside of the src directory that ends with .ts extension for now. And now if I just test.js, I delete this one, I come here, re-execute my command, you'll see that this time test.js has not been compiled. But if you take a look at this src folder, we have this main.js. Okay. Now similar to this include option, you also have this exclude option like this. And by the way, I've just included all of the subfolder TypeScript files also in this include option. Now here's the thing. With exclude command, I can specify which file I want to exclude. Let's say inside of this src directory, I have this another folder called exclude, okay? And then it contains a file called exclude.ts. This file won't be compiled. So now I can go to my ts config and then I can specify that src folder has this exclude folder. Just do not compile this. So now when I execute my command again, tsc, you'll see that it is not compiling that exclude folder, right? So if I just comment it out, I execute my command again, you'll see that it is now compiling that file also. All right. Now, if you notice carefully that right now what is happening is that all of these files, TypeScript compiler is compiling those files and putting them to their exact location. Let's say you want to change this behavior. So we can use this another option called out directory. And here we can specify that it should compile all of the TypeScript file to this dist folder. So now when I execute my command, and now you can see that it has created this dist folder. If I click on this, you'll see that it contains this main.js file. Now the interesting thing to know at this point is that just because we have set this root directory to src folder, TypeScript compiler is going to map the entire folder structure of the src folder to the dist directory. Let me show you. So right now, if you take a look, we have this main.ts file. That is why we have this main.js file over here. Then we have this exclude folder. And since we have told TypeScript compiler to not compile this file, it has not created a compiled JavaScript for that. So if I remove this one and I rerun my tsc command, you'll see that it also created an exclude folder right inside of this dist directory that contains this exclude.js. Perfect. Now some of the other important option you should know is this strict mode. First of all, according to my experience, you should always set this to true. This does 2 to 3 very important things. Now the strict option in TypeScript turns on the highest level of type checking rules to help you catch mistakes early. And when you enable strict mode, you automatically switch on these stricter checks. For example, strict null checks. It forces you to handle null and undefined separately, reducing null or undefined related errors. It also enables this option no implicit any, which basically means that TypeScript cannot infer any values as any. Any is basically a type in TypeScript that basically signifies that this variable can hold any kind of value. But if you use something like any, you basically defeat the purpose of using TypeScript altogether. So that is why it is almost never recommended that you use something like any. Strict option also enables strict function types, which basically means that function parameter and return types are compatible. To keep things simple, you always want to keep the strict mode to true. Alright, now there's definitely a lot more options available inside of this ts config. These were some of the basic options. Okay, now at this point we have this basic idea about TypeScript configuration. Let's actually start learning TypeScript now. I'm going to zoom in a little bit and then I'm going to delete this test.ts file. I'm also going to delete this main.js and this exclude folder. And then I'm simply going to execute this command tsc-w, which is going to start the TypeScript compiler in the watch mode. Now what this is going to do, it is going to watch all the files inside of the src directory, and any change that I make in this file will automatically trigger a compilation. So for example, if I add a dot over here, you'll see that file change detected, starting incremental compilation. And you'll see the latest changes right inside of this dist folder, main.js. Perfect. Let me also delete this exclude folder from here. All right. Now JavaScript has 7 primitive types. Primitive is a data that is not an object. For example, string, number, boolean, null, undefined, symbol, and big int. And in TypeScript, you can explicitly declare the type of a variable using these primitive types. For example, take a look at this message variable. In order to tell TypeScript that this message variable is only going to contain a value of type string, I just need to add a colon here after the name of the variable and then add a string like this. With this, I'm explicitly telling TypeScript that message can only have string as a value. So what this means, later if I try to assign a different kind of value to this message variable, TypeScript is going to throw me an error that number is not assignable to type string. Okay, and similarly we can have another variable. This variable can have a type of value of number like this, and if you try to assign a different kind of value to this variable, for example, let's say string, you're going to get this error that type string is not assignable to type number. Now with these keywords string and number, what we are doing is we are explicitly telling TypeScript that this variable is going to hold this kind of value, but that is not necessary. And what I mean by that is, let me get rid of this code. So even though I do not include this string keyword over here, when I hover over this message variable, you'll see that TypeScript is still inferring that message is going to contain a string value. This is what it means, let message, and the message is going to be a string. This is called automatic type inference. That means you do not have to specify the type of value a variable is going to be holding. Almost 95 to 99% of the cases, TypeScript is going to do that automatically for you. And it's a good practice that you do not explicitly declare these things, because TypeScript automatically gives you this automatic inference. So by just adding this another keyword, you are making your code a little bit bloated. So the point is only explicitly declare when it is absolutely necessary or when you think that TypeScript is not inferring correctly. Now similar to string and number, I can have a variable, let's say is subscribed. And if I initialize this variable with a value, let's say true, what is true? Okay. TypeScript will know that this variable can only have a Boolean value. So the value of this variable can either be true or false, right? And if you try to assign any different type of value, you're going to get this error. Now, one of the things to keep in mind is that you may think that you are getting these errors, so TypeScript is going to actually do not compile this code, but that is not correct. Let me show you. So in this code, you'll see that we have created this variable is subscribed is equal to true, and then we are assigning it a number value. This is clearly wrong. But if you take a look at this main.js file, you'll see that it contains that code. So what is going on? Well, the reason for that is that TypeScript does not automatically comes in your way of compilation. And in the beginning of the video, I told you that TypeScript only works during development time. So it is just here to tell you as a friend that you are doing probably something wrong, but it does not come in your way in terms of what code you want to write and what code you do not want to write. Now, if you want to do not compile your code when there is an error, you can configure an option inside of this tsconfig file. I think it's related to emit. Yeah, no emit on error. So we can set this to true. What this is going to do is that if there's an error, TypeScript is not going to compile that code for you. So if I actually delete this main.js for now, I make some changes over here, you'll see that it is not compiling the code to the disk directory because we have explicitly disabled that particular thing. I'm going to remove this option for now. I'm going to come here and now you can see that it is started to compile that code again. Okay, now, so this makes sense in case of primitive values, right? What about arrays and objects? How do you declare types for them? Let me show you. So imagine I have this array called numbers and it can have 1, 2, 3, 4 numbers like this. Now because of automatic type inference, when you hover over this, you'll see that it is TypeScript is giving you something like this. Now what this syntax basically means that numbers is going to be an array of numbers. And you can explicitly declare this right over here by doing something like this, that numbers is going to be an array of number. Okay. Another syntax you can use is you can do something like this. You can say array, and then within these angle brackets, you can specify that this array is going to be of type numbers. That essentially means that this array can only have numbers. So then later, if you try to push something that is not a number, you are going to get this error. Argument of type string is not assignable to parameter of type number, right? Okay, let's say you want this array to have both numbers and string. How can you do that? Well, the thing is you can specify that this array can also have a string. So what this means is that this array now can have both numbers and string. Okay, now what about objects? How would you declare types in objects? Okay, let's take a look. Imagine I have this user object. Okay, now this user object has some of the properties like name. I'm gonna add my name over here, and then I also have this age. So let's say I am 99 years old. And then to specify the types for each of these properties and methods, let's say I can do something like this. After this user variable name, I will add a colon and then this object like structure. And now I'm going to say that this object is going to have a name property And the value of this name property is going to be a string. And then this object also going to have an age property, and it is going to be of type number, right? And if you hover over this, you'll see this exact type definition. That name is going to be string, age is going to be number. And automatic type inference works in this case also. So even if you do not include this, TypeScript is still going to infer that automatically, as you can see over here. But let me include that back. Now, if you find this code a little bit harder to understand, what you can do, you can actually cut this, create an interface and reference that over here. So what I can do, I can create an interface called user, and then I can add these things over here. This is kind of same thing. You can either add this directly over here, or you can create an interface, give it a name, and then you pass this name over here. If you want to make any of the properties optional in your object, what you can do is you can just add a question mark like this after the end of the property. So what this means is that age property inside of this user object may or may not exist. Now, instead of creating this interface, you also have this option of creating a type alias, and the syntax for that is a little bit different. So let me comment it out. Instead of interface keyword, I'm going to use type, and then I just need to add a equal sign like this. The type alias also help you to define the structure of your object in this sense. But there are a number of differences between type aliases and interfaces. Now, the first one is related to their purpose. Interface basically describes the shape of objects, for example, methods and properties. Now, type aliases can do that also, like how we are doing it over here. But type aliases are more flexible in a sense that they can also handle primitives, unions, intersections, which we are gonna be learning in a little bit of time. Okay, now the second important difference is that interface can be merged. And what I mean by that is, let me actually comment out this type for now. I'm going to uncomment this interface user. And then let's say in a different file or different part of your code, you decide to create this interface again called user. And then you add an address property also. And this address is going to be a string. Now what TypeScript is going to do in this case is that it is going to say that user object now contains three important things: name, age, and address. The age is optional, but address is required. So when I hover over this, you'll see that property address is missing in type name, age, but required in type user. So what this is telling you that user should have an address property, but your user object does not have an address property. So if I come here and add my address like this, you'll see that I'm not getting any error. So this is what we mean by interface merging. If you create two interfaces with the same name, TypeScript is going to combine all of their properties and methods, and then the final interface will contain all of those properties and methods. You cannot do something like this in case of type alias. So once you define a type alias like this, you cannot do something like this again, that I create this type user again, and then it is going to have an address property which is going to be of type string. You'll see that TypeScript won't allow you to do that. Duplicate identifier user. So you cannot do something like this with type aliases. Another difference between a type alias and interface is that interface can be extended. For example, let's say I have this interface called user, and then I'm creating this another interface called extended user. Now what I want this extended user interface to have is that it should also have all the properties and methods of the user interface. So what I can say this extends the user, and then I can add an address property which is going to be of type string. Now, if I use this extended user over here, you'll see that I'm not seeing any error, because now extended user contains all of the three properties: name, age, and address. You cannot do something like this with type aliases. However, one of the benefits of using type aliases is that they are just not limited to objects. Let me show you what I'm talking about. Let me get rid of all of this code for now. Okay, now take a look at this piece of code. So I've created this type alias called credit card, and then I have created this another type alias called PayPal. Okay, And then I'm creating this another type called payment method, and the payment method can either be credit card or PayPal. So this works more like an or operator in JavaScript, and we call this union type. Payment method here essentially becomes a union type, and this essentially means that it can have either credit card or PayPal as its value. And just because this is a union type, you can pass anything over here. So you can even specify that we can have any kind of string over here as its value in payment method. You cannot do something like this with interfaces. Okay. So when you use this kind of syntax, this basically means OR operator, and it becomes a union type that this payment method can either have this credit card or PayPal. We also have the intersection type. So imagine this, we have this type admin, then we have this type auditor, and then we have the super user. Now this super user is going to have all the properties and methods of both admin and auditor combined. So it should have all these properties and methods that is present in both of these objects. So for that we use an and symbol like this. Here super user becomes an intersection type. Alright, okay, so at this point we now understand how do we declare types in case of primitives, how do we declare types in case of arrays and objects. What about functions? How do we do that? Well, functions are also pretty straightforward. Let me show you. You can see that here I have this function called add, and then I'm saying that I'm going to accept two parameters in this function, a and b. Let's say the a is going to be of type number and b is also going to be of type number. And then you'll notice that after this parenthesis, I've added a colon, and then I've specified this number. Now what this means is that this function is only going to return number no matter what. In all of the scenarios, it is always going to return a number. So here I'm specifying what type of values this function is going to be accepting, and here I'm specifying what type of value this function is going to return. Now if I want to make any parameter of the function optional, I can again add a question mark like this. And now you can see that as soon as I do that, TypeScript start giving me this error that b could be possibly undefined because you have made that optional. Now what that means in the practice is that even when you do not pass this b parameter, here TypeScript is not going to complain that. So within this function definition, you need to handle that particular scenario. Let's say by checking if b does not exist, we'll simply return a from here. Alright, now you can also assign a default value to your parameters. So what you really need to do is you just need to add an equal sign, and then you need to add your default value. Do keep in mind that this is not going to work with optional parameters. So make sure you remove this question mark from here also. So now b is going to have a default value of 2 in this case. And even though you do not pass it, we're still going to get 5 plus 2, which should be 7. Sometimes what happens is that we know more about the expected values than TypeScript does. So in those scenarios, we can use type assertions to tell TypeScript about it. Now one very good example for type assertion is something like this. So in here what we're doing is we are basically trying to get an element from the DOM that has an ID of username, and then you'll notice this keyword as and then HTML input element. So what we're doing here is that we are telling TypeScript that I know for a fact that this username is going to be an input element only. And since this is an input element, I can use this dot value method on it and set its value like this. But if I do not specify that, TypeScript is going to complain. Let me actually get rid of this. You'll see, first of all, this is complaining to me about that username field is possibly null, which is definitely a possibility. And then it is specifying that property value does not exist on type HTML element. So this is treating this username field as the HTML element. And then in order to fix this, we need to actually tell TypeScript that no, this is not going to be an HTML element. This is going to be an HTML input element. And now TypeScript is aware of all the properties and methods related to input, and it is not complaining to us about that. Do keep in mind when you do type assertion, you are telling TypeScript two things. In this case especially, the first one is that you are telling it that I know for a fact that this field is going to be present in the document object model when I am trying to access this field. Okay. And the second thing is you are telling it that I know for a fact that this is going to be an input type of field. This is important to understand because now TypeScript just assumes moving forward that we have this field and we can set its value. So you need to handle all those cases manually when this field does not exist, because if this field does not exist, it could throw an error during runtime. So probably what we can do here is we can also say that this could either be an HTML input element, or this could also be a null or undefined, whatever the default value is when we do not get any element. I'm not sure about that. Let's go with null for now. And now you'll see that this is telling you that username field is possibly null. So now what we can do, probably we can add an if condition that only if username field exists, we are going to try to set its value. Now this code is not going to give us any runtime errors. So the point is, try to keep type assertions as few as possible. And even when you do that, you need to check things explicitly for runtime errors. Alright, now TypeScript also supports programming concepts like classes and inheritance. For example, I have this class person. Here I'm specifying that this is going to have two variables, name and age. Name is going to be of type string, age is going to be of number. And when I'm going to be creating a new instance of this class, user should be passing name and age of these type. Then I'm going to set these values. And then we have this describe function, which simply logs this information, right? When we create a new instance, we need to pass this information. Now, if I try to do anything else, so let's say I try to pass a Boolean value here, this is going to complain that you cannot pass a Boolean value. Argument of type Boolean is not assignable to parameter of type string. This actually makes sense. So here I need to specify the name of the person like this. Now with classes, you also have these access modifiers available to you like public, private, and protected. And what that means is that if I set my age to, let's say, private, I am not allowed to access this property outside of this class instance. That means if I try to do something like p1.age, you'll see that TypeScript is complaining that property age is private and only accessible within class person. But if I remove this private keyword, I do not get any error and I can simply access that age property. Now the next concept you need to understand is index signatures. Index signatures allows an object to have an unknown number of properties, all following the same type rule. So imagine I have this phone book variable, which is going to be an object. And then let's say in this phone book, since this is an object which is going to have a collection of key value pairs, in the key I can specify my name and then its value is going to be my number. Okay. Now if you hover over this, you'll see that TypeScript is inferring that this is going to be an object that has this just one property named Aditya, and its value is going to be string. But again, this is a phone book, so this is going to have not just my name but a lot of other people also. So in this specific scenario, we can use the concept of index signatures. I can actually create an interface. Let's call this phone book, and then this interface is going to have its keys. I'm calling these name, and then these name are going to be of type string, and its value is also going to be of type string. And then I can reference this over here, and now TypeScript will know that this can contain a lot of properties of type string and their value is also going to be of type string. So now if I want, I can actually come here and I can do anything, let's say rock, and set its value to this. You can see that we are not seeing any error. But if I remove this, you'll see that TypeScript will start complaining about that property rock does not exist on this type. So we can use this index signature. The next very important concept you need to understand is generics. So imagine I have this function called pick a random item, and then it accepts an array of items for now. And then from those items, it just returns a random item out of this function. But if I hover over this pick a random item at this point, you'll see that it is treating this items as anything, and then it is also saying that you can return anything out from this function. Now this is a very bad thing to do, because if the TypeScript is inferring something as any, What that means, you have technically disabled TypeScript in your project, at least for that specific code. So in this particular scenario, the automatic type inference is not gonna work for us because TypeScript is telling us that you can pass anything to this function and then you can return anything out of this function. Let's make this a little bit specific. I'm going to say that this items is going to be an array of, let's say, numbers. And then this function can only return number. Okay. Now when I hover over this, you'll see that the type definition has changed. Okay. So that means if I have this array of numbers 1, 2, 3, 4, 5, and then I do console.log, I call pick random item, I pass my numbers array to this one, I call this, I'm not getting any error, and this actually makes sense. Okay, but what if I have a different kind of array? Let's say I have this array of colors, and in this one I have this red, green and blue, and now this time I want to get a random color, so I can call pick random item, I can pass my colors array, and then I'm starting to get this error that argument of type string is not assignable to parameter of type number. And this actually makes sense when you think about it, because here we have specified that this items is going to be an array of numbers, and it is going to return a number. Now, one of the ways to fix this problem is to create a different type of function with a different type definition. But that is not going to be a very good option because you'll be duplicating your code unnecessarily. What if we could use the same function for both of these scenarios and also get the type safety for both of these scenarios? Well, TypeScript generics allows you to do that exactly. And to do that, I just need to do one thing. The first thing that I need to do, I need to create a generic type. We usually call this t, and then instead of this number, I'm going to say that this array is going to be of type t, and then I'm going to return this t type out of this function. So now when you do something like this, based on the usage, TypeScript is going to infer different things. Let me show you. If I hover over this one, you'll see that items is going to be an array of number, and this pick random item in this case should return a number. So we are getting the correct type safety here. But if I hover over this one, you'll see that here the items is going to be an array of string, and it is going to return a string out of this function, which actually makes sense. So now, just by adding this generic type, we have handled both of these cases, and we are getting type safety in both of these function calls. Okay, but what if our array contains both of these things? Let's say numbers and colors. And now we have 1, 2, 3, 4, and then let's say red. What happens in this case? Well, nothing. So if I call this pick random item and then pass my numbers and colors, you'll see that TypeScript is not complaining about anything, because when I hover over this, you'll see that it has created a union type. What that means is that TypeScript has automatically inferred in this case that the passed array can have either string or number, and we can return either string or number from this function. And this actually makes sense when you think about it, because if you're trying to pick a random number, random item from an array that contains both string or number, it could either return a number or a string. Perfect. So this was about generics and TypeScript. Okay, now let's talk about some of the utility types you need to understand in TypeScript. Utility types are built-in helpers in TypeScript that let you transform or create types based on existing ones. And it will all make sense when you see the actual code. Let's say I have this interface called user. Now this user has some properties like ID, which is going to be of type number for now. And then name is going to be of type string, and then isAdmin is going to be a type of boolean. And then let's say within your code base somewhere, you have this function called update user. This expect you to pass this user object, which is going to be of type user. And then it also expect you to pass what type of information you need to update. What information you need to update? Do you need to update name, isAdmin, or both of these? Something like that. So in this specific scenario, what we can do, we need to basically get a type of this user interface in which all of these fields are optional, right? So I can use an partial utility for that. And in this partial, I can specify user interface. And then within this function, I'm just gonna say, first of all, we'll get all the properties and methods of the user, and then we'll override with what the user has provided with this update object. And it's also a good idea that we add that from this function, we'll be returning a user type only. What this means is I can simply call this update user by passing these two arguments. Let me quickly create a user object also. User is going to be of type user, and then let's say ID is 2, name as Aditya, and then is admin is true. Now here I'm going to say the user, and then in the second argument I can provide an object that can have any of the properties that I want to change. So let's say I want to say that the name of this particular user should be Rock. It is going to update that, and then it is going to give me the latest user data, and then we can work with this information. If you do not use this partial over here, it is going to complain that you need to pass all of the properties that is present inside of this user interface. So with the help of partial utility, you can do something like this. Now, similar to this partial utility type, you also have this required utility. Imagine I have this task interface like this, and then I have this function called markDone. And here I can just use this required utility to make all of the properties and methods in this one required. That means when the markDone is called, user should be providing both title and done to this function. Now the next utility type you should know is this read-only utility. So imagine we have this interface car, which has these two properties, brand and year. And then I'm creating a new car with a brand and year. And here I've specified that the car properties that I have over here, it's going to be read-only properties. Now what that means, when you set the properties to read-only, you cannot reassign any value to those properties. So here, initially I've said that the brand is going to be Tesla. But later, when I'm trying to reassign a different value to this property, TypeScript is throwing me this error that you cannot assign to brand because it is a read-only property. So with the help of this read-only utility type, you can make any interface or type and all of its properties read-only. Next utility type you need to understand is this record utility type. Now in this one, what we are doing is we are creating this country code type, which is going to be of type string. We have also created prefix type, which is going to be of type number. And then we have created this phone prefixes. And here we are using this syntax basically. Now just to keep this really simple, in this country code, what I'm specifying is the type of the key that is present over here. Because I have said that the prefixes is going to be of type phone prefixes. And then with the help of this country code and prefix, I'm basically defining the type of this key and value. Think of it like this, that for each of these records, I'm basically defining their type. The key can be of country code, which is going to be of type string. And then this value is going to be of type number from here. So that is why when we try to assign this US a type of value that is not a number, TypeScript is telling us that type string is not assignable to type number. So I can do something like this. This is very similar to index signatures that we have learned in the video. Alright, now the next utility type you need to understand is this pick utility type. So imagine that we have created this interface called person. And through this interface, we can create another type called, let's say, name and age. We can selectively choose what type of properties that we need to pick from this interface, in this case, name and age, right? And then if I hover over this, you'll see that this does not contain address. Now, similar to this pick, you also have this omit utility available like this. So what this means is that do not include name and age. If I hover over this, you'll see that it just contains address for now. Perfect. Now do keep in mind that this is not actually modifying the original interface that we have created over here. No, we're not doing that. It's just that it's creating a different type alias with the help of these utility functions. You also have this exclude utility type available to you. Imagine that you have this union type, and it could be either be string, number, or boolean. So what we can do, we can filter out or extract some of the things out of this union type. For example, in this one, what we have done, we have specified this union type over here, and then we have said that just exclude string and then return everything else. So this is going to be another union type of number and boolean. Similar to this exclude, you can also filter on the basis of nullable value. So for example, maybe number is a union type and it could either be number, null, or undefined. And here I'm using non-nullable utility type to basically get all those types that are not nullable. So now when I hover over this, you'll see that this only contains number. Now the last utility type that we're going to learn in this video is going to be the return type. Now return type is a utility type that you can use to get the return type of a function. For example, take a look at this one. We have this create user function which accepts name and age, and then this returns this object with name, age, and is admin. And what we can do, we can actually get this user type using the return type utility that we have present. So in this one, we just need to specify the type of create user, and then we'll get something like this. Okay, so at this point, we have this basic idea about what is TypeScript and what are some of the basic concepts available in the TypeScript language.